All right, sweet. So we have a lot of assignments due today. Just wanted to highlight kind of what some of the analytics are looking like. So super cool to see like every student completed lab 1. Almost every student completed homework 1, which kind of shows me that, all right, students know where the EdSTEM is. They're able to do the assignments. Coming down, even like lab 2 ended up being pretty solid. Where was it? Week 2, lab 2. About 90% completion. If you haven't quite done this, the one that I'm noticing here is like the quiz survey. So maybe you did the quiz survey on a separate tab, but then forgot to come back and mark true for the question. So really just make sure if you think you've done all the assignments, like these first 6, that you go and make sure that you actually have a check mark by each of them. So your page should look like this, where it should have the check mark. I've like hidden the bonus problems, so you should actually see like the check mark if you've completed these. So especially there's some that stood out. So lab 2, make sure you went back and marked true for the quiz survey after you completed it. And then for homework 2, I noticed like for this quiz for the buggy code, like this one's really just based on completion. So I put up the answers in the lecture video, but you have to actually go and press submit for every question and make sure that you see the check mark for this one. So just to show, like, you have to actually go and click the submit button for each of these options, and then you should see a check mark here. So really make sure if you've done homework 2 that you double check that you actually submitted each of these and that you have the check mark. Just looking at the analytics there, it does seem like that one has the lowest completion rate, even though I'm sure most people did it. So week 2 is looking good. Week 3 is where we kind of see a little bit of a drop off. So if you need like an extra day extension, I know we put a lot of assignments due today. If you need an extra day, you need to email me. Like I'm not going to keep extending it for everyone, but if you just need an extra day, just let me know, hey, can this be due like Tuesday instead of today? And 99% of the time I'll say yes. But I just want you to communicate and be proactive about that. Any questions there? The sum of digits problem, I think on the end of homework 2, kind of a lower completion rate at 60%. Again, in the you can get to like all the lecture slides and recordings from the EdSTEM, but in this lecture video, I go over how to do the sum of digits. So again, we see like a 60% completion for sum of digits. If it's unclear, come and check out the video. At the very end of the video, I think around the 27-minute mark, I walk through how to do that problem. Yep. So again, the resources are there, the support is there. The assignments are due tonight. If you need an extension, email me, and I'll probably grant it, but you have to be proactive. Yep. Sweet. All right. All right, let's do attendance. Portal. Oh. All right, lecture 1. Okay. All right, Alpha. I think it's been coming into the later ones. Marshawn. Troy, Boxton. Yeah. Kadar, Coleman. Justin Davis. Sandro. Aaron. Christian Fisher. Jakylin. Calvin. Freddie. Matthew. Donovan Jenkins. Maybe he dropped it. Christian Johnson. Kadar Johnson. John Massey. Jamel. Idris. John Aliga. Troy Peterson. Mark Ross. Yep. Rashad. Yep. Zach Sharp. I think he wasn't feeling well. Ronald Smith. Nehemiah. Khalik. I think he just emailed. Not feeling well. Paul Wilson. And Isaiah. Sweet. All right. Again, if you want, you're always welcome to come to the 1 p.m. or the 2 p.m. lecture. 2 p.m. lecture has about 5 people, so definitely if you want more one-on-one kind of smaller class size, I definitely recommend it. And then I'd come back and update your attendance here. Sweet. All right, let's get started with while loops. So for today, we're going to do one more recap on if statements, just because the weekend has passed, so just making sure people are up to speed on that. If statements and what we're going to learn today with while loops look very similar. So using relational operators, using the parentheses and putting your condition in there is all going to carry over into today's lecture. We're going to do a Kahoot, then compare exactly the difference between if statements and while loops, and then go into the syntax for while loops. Any question before we get started? All right, let's do it. So examples that the class came up with, examples of if statements in everyday life. If your phone is low on charge, then charge it. If you have a certain amount of money, you can buy a certain combo. If you're older than 16 and you pass the driving test, then you get your driver's license. And if I'm out of eggs, I'll buy the eggs. Else, I'll be able to make an omelet. So we want to be able to represent all of these cases in code. Using flowcharts to see how we can visualize something in code, we started off with the absolute value example. And the reason why absolute value is a good example was we only do something for the negative numbers. For the positive numbers, we can just print it out exactly as it is. But for the negative numbers, and the way we checked if something was negative was we did value is less than 0. Then in that case, that true case, we do something specific. So we would multiply the value by -1. And again, we would only do that if value is less than 0. So there's no way to write an absolute value code that works unless you know about if statements. Any questions here? All right, the syntax. We start off with the keyword if, if. So you couldn't name a variable if because that's a special C++ keyword. And whenever the program sees the word if, and it's not in quotes, it will take that to mean that the code is about to branch. And it branches based on what's in the condition statement. So you put the parentheses and then a condition, and this condition must come out to one of two values. What are those two values? True or false. Whatever's in the parentheses must be true or false. So that can either be a bool variable, because a bool variable is always true or false. Or it's a statement that uses one of these relational operators. So you can check if two values are equal to each other. You can check if one value is greater than another value. You can check if two values are not equal to each other. Each of these expressions will result in a true or false. Yep, all this still making sense? Yep. So that's just for the if case. If we wanted to do something different for the false case, for example, in this eggs example, we said if we have at least 2 eggs, then we'll make an omelet. That's the true case. Else, the false case, we go and buy some eggs. So to represent this in code, we again start with the special keyword if. The condition will either be true or false. If it's true, all the code in the first set of curly braces will run. Else, otherwise, if it's false, then everything in the last set of brackets will run. And again, only one of these two code segments will run. There's no possibility that both can run. Yep. All right. The final example we had building on this structure is the if, else statement. And the else if can be useful if you have different outcomes. So we did the dining hall example with the Chivers dining hall. And for that one, we had kind of 4 different outcomes. It could either be breakfast time, lunchtime, dinner time, or closed. So we started with if hours is greater than or equal to 7 and less than or equal to 10. So remember we used the and statement with the 2 ampersand symbols. Then we would tell the user it's breakfast time. Else, if the hours fell between 11 and 15, then we print out lunch. Else, if it's between 17 and 21, it ends up for dinner. And then if we wanted, we could do another else if for all the other times to figure out if it's closed. Or if we know it's not breakfast, lunch, or dinner, then we can just write the word else, and we know all those other times it will be closed. So again, the else statement here is optional, but it's used, I would say, at least 80% of the time, because there's usually some other case that you want to cover, but you don't always have to include it. In the absolute value example, for example, we didn't need to use the else statement. So the if statement is always mandatory. The else if and the else are optional based on what your code is doing. Yep. All right. Yep. Any questions? Again, it's kind of a lot of information to see on slides, but I think everyone who came into lab for last week's lab, lab 3, were able to complete it in the time. Hopefully it made sense with the extra practice. We'll be using this throughout the semester, so if statements are super important. The final if statement part we're going to cover, or that we have covered and that we're going to recap today, is the nested if statement. So in the nested if statement, the example we did was with Shiver's dining hall, where instead of just printing out lunch, we wanted to say if it was a special fried chicken lunch. And for that, we put the if statement inside the else if. So you can nest if statements inside of other if statements. The important thing is that you indent the code properly. So again, in the Shivers Hall dining example, we were checking if it's breakfast time. We did this in the outer if statement. We call it like outer if statement and inner if statement. So in the outer one, we checked the hours. If the hours were greater than or equal to 11, less than or equal to 15, then we knew it was lunchtime. And then we created another if statement inside of it, the inner if statement, or the nested if statement. And within here, so this code will only run if it's lunchtime. And in here, we check if the day is Wednesday. And if it is, we printed fried chicken lunch. Otherwise, we printed lunchtime. Any questions on this piece of code? Okay. So hopefully, you kind of see how complexity can build. So each concept by itself is relatively straightforward. What makes computer science hard is when you start chaining together these different concepts into one. So in this piece of code, we did stuff with data types where we had to say what data type hour was. We did stuff with variables where we defined the variable hour and day. We did stuff with the assignment operator where we used the equal sign. We did stuff with relational operators where we used greater than or equal to. We used logical operators with the and sign. We used cout and cin with the stream operators, right? So in just, what is this, like 15 lines of code, we literally use every concept that we've learned so far in this class. And that's why I really emphasize that it's super important that you do lab 1, that you do lab 2, that you do lab 3, because you won't be able to do lab 4 without those 3. Yep. Cool. All right, let's get into a Kahoot. All right, again, you can join on your phone or laptop, kahoot.it, or you can scan the QR code. All right, we should have 20 people on here. I think in terms of difficulty, it's kind of between the first one and the second one that we did. So again, still try to prioritize accuracy if you're trying to get on the podium. And then the tiebreaker is speed after that. But you don't get points if you get it wrong. So really make sure you read the problem. Yeah?
If you came in the class late, do I come to you after like class so you can do attendance today?
Sorry, can you repeat that one more time?
I said, whenever you come to class late, do I just
I'll-
talk to you after lunch?
Yeah, at the end of class, I'll mark attendance.
Okay.
All right, I think we're missing 3 people. Kahoot.it, game pin 680-8141. Two more. Again, this isn't a quiz or anything, it's just for fun. Let's get everyone in here. One more person. Sweet. Let's do it. All right, again, on your phone or your laptop, you'll mark the color of the option that you think is correct. So it'll be blue for true, I believe. Blue for true or red for false. All right. So how would we read this in English if we were just reading it out loud?
Hello is world.
Yeah, so is hello equal to world? So we're comparing two strings. The double equal sign means the equals operator. And so we're checking if these two are the same and they're different words. They're not, so it'd be false. Cool. All right, Sandra with the early lead. Second one. Okay. First off, what data types would these be if we had to assign them to variables? Doubles, because there's a decimal. And then how would we read this out loud in English? Okay, and that would be true. Cool. All right, close at the top. Another one. A little bit more involved this time. Well, I guess I didn't put the data type, but it should be int x equals 7. All right, split here. So let's step through it. So x is equal to 7. This first sub-expression, how would that read? Okay, and if what is the value of x?
7.
All right, is 7 less than 3? Okay, so that's false. How about the second one? X is greater than 6. Is that true or false? So we have one false and one true. What does this double pipe symbol mean? Or. So if we have a false or a true, what does that come out to? True. Any questions there? Because we're evenly split. Yeah.
So it's basically like whenever you have like you're trying to like solve for something, if there's a false and there's a true, it automatically says true because there is a true in there, or is it if there's a false? Which one is it?
Yeah. So in the or statement, as long as there's one true, the overall will be true.
Okay.
Yeah. And I'm trying to think of like easy examples where, because it does kind of map to how we think about it in the real world. So in class we talked about the movie discount example. So if the user is a child or they're a senior citizen, we give them the discount. So as long as one of them are true, then we give them the discount. If they're less than 10 or they're greater than 65. Or if it's something like, what's like another example of an or in real life? Can anyone think of anything? What? Yeah, in your real life.
Go to class or stay in your room.
Yes, but that'll end up being like an if else.
Like if you have a menu and you want to select an item, if you choose an item, then you'll receive an order. If you don't choose anything, then you're just gonna be waiting.
Yes, but that's still kind of like an if else. Like if you
Well,
order.
the different selections would be the or conditions. It's like,
Okay. Yes. Exactly. So if you picked combo 1, or you picked combo 2, or you picked combo 3, you'll get food.
And then ask for your.
You just still get something.
Yeah, as long as you do one of the options. As long as one of the options are true, the overall thing is true. Like you'll get food or whatever it is, right? Cool. All right. One more true or false before we get into code stuff. Let's really try to make sure everyone answers. Okay. So this first part, is it true? 5 is less than or equal to 5.2.
Sure.
That's true. And is 3 different than 4?
Yes.
So both of them are true. And then what does this double ampersand symbol mean? And. And what does it mean if there's an and?
Both of the conditions are true.
Yeah, so both have to be true for the overall statement to be true. And so in this case, because we have true and true, the overall answer ends up being true. Yep. Any questions there? Okay. This next one I'm going to show, or let's see. Okay. So this next one, we're going to output some code, and you have to say what the output is. If you need to get a little bit closer to see it, you can come up. Okay. All right, let's step through it. Can everyone see this okay? Okay. So at the beginning, we define a variable age. It's of data type int, and we assign it the value 5. So at line 6, what happens? All right, and is that true or false?
False.
All right. If it's false, what line gets executed next?
8.
So we skip line 7. Line 7 would only run if this condition was true. But because it's false, we skip to line 8. What happens at line 8? And is it true or false?
True.
It's true because 5 is greater than 4. So what line executes next?
Line 9.
9. So we print out B. After that, what line runs next?
13, 12.
Yeah, so we skip, once one of these statements runs, we skip everything else. So that's why it's not like the green one. It's not B and C. It's only B. So again, only one of the 3 will run. And because the first condition was false and this one was true, it printed out B. Any questions? Okay. Jamel holds the lead. All right. So in this problem, I have some code to tell the user if they're too young to vote, if they're less than 18, but there's an error in the code. Again, you have more time on this problem for accuracy. $15 seconds, try to get your answers in. Also, if you know the answer, think about how you would fix it as well. Okay. Cool. So let's take a look at the code again. All right. So what's going to happen when we step through it? Line 5, we define a variable int age, so there's a spot for it in memory. What happens at line 7? Yeah, so we're trying to check if age is less than 18. It is the correct relational operator because if they're less than 18, they're not allowed to vote. But we don't know the value of age at this point. So it's going to be some random value. So sometimes your code is actually going to work, and sometimes it won't. And again, those errors are the toughest to fix because it's not like a compiler error. It will run, and it will give you some random value. So how could we fix this if we wanted the code to run properly?
You have to declare it. So
Yeah, so
age equals.
So there's 2 ways, right? One is we use the assignment operator. So we could just say age is equal to some value. and we use that assignment operator with the single equal sign. And we would have to do that above line 7, right? If we did this after line 9, it would be too late. We would have to do it before it's used in this conditional statement, and we could say age is equal to 7, for example. The problem if we do that, though, is that the code will always do the same thing every time. So what's the other way that we can put a value into age? cin, right? So we ask the user, input your age with cout, and then with cin, we do the 2 arrows going into the age variable. Yep. Mm-hmm.
Would that ever run? Like, doesn't the computer reserve memory that's like below a certain threshold? So there's never going to be anything below like 18?
Yeah, so I'd say 99.9% of the cases, it will have a value greater than 18. It could put a negative number, though. So
Oh,
actually,
yeah,
I wouldn't say
yeah,
99%. A lot of times it could be a negative
Yeah,
number.
in that
Yeah.
case,
Okay. One more question, and then we have a poll at the end. 4 players on a hot streak. Last one. This code is going to check the password of the user, but there is something wrong with the code. Five more seconds. Get your answers in. Wow, I should have put more time in. Alright, sorry, I feel like maybe some people slightly ran out of time. Sorry, yeah, I should have put more time on that one. Okay. This is the most common mistake that I've been seeing in Lab 3 and even on Homework 3. Okay, so let's step through it. String attempt. So we ask the user, what is your password? We store it into attempt. So are the cin and cout statements correct so far? Yep, arrows are the right way. So speaking out to the world with cout, data flowing into attempt with cin. And then line 10, what happens? If attempt is equal to password 123. Yeah, so what operator is it if it's just a single equal sign?
It's like a variable.
Yeah, the assignment operator. So what this is going to do is it's going to store password 123 in attempt. And then I think it's just always going to be true because it's going to assign it and it's going to assign it successfully. So then it's going to say true and then it's going to print out welcome to the website. And so if you were like in charge of a website, you would essentially allow anyone to hack into your website with this code, right? Because you would always allow the user access because this would always be true. So how could we fix it?
Put another equal sign.
Yes, so we would want it to be attempt equals password 123. Yeah? I mean I can kind of keep saying it until you make the mistake in lab. It might not fully stick, but whenever you're comparing something, it has to be 2 equal signs. Yep. All right. Poll. Last question. Just how do you feel about the stuff in this Kahoot? Again, the exam will be very similar to questions like these. So like the written part of the exam will be stuff with relational operators, stuff with the and statement, the or statement, putting up like code that needs to be debugged, and you pointing out what the error is.
What is it again?
Wednesday, September 28th. So coming up in 2 weeks. And I think that's midterm week for all of your classes. So all of your classes will have your midterm sometime in that week. And we'll probably do it on that Wednesday. Yeah. Yeah, school's moving fast. Yeah. For this class, you pretty much know everything that's going to be on the exam. The only topic is that we haven't covered yet is the while loop. So we're going to do that all of this week. Next week, I'm going to try to figure out what concepts people want more practice on, and we'll kind of have review lectures. So maybe one more lecture on while loops, and then Wednesday and Friday will be review topics for stuff that people want more practice with. And then Monday the 26th, so that Monday before the midterm, it will just be doing practice problems in class, and then seeing if people have questions. Sound good? All right, let's see the final standings. In third place, 7 out of 7, Mark, congrats. Well done. Kedar, cool. And Jamal. Cool. We'll give him a round of applause. Good work, everyone. And Paul and Isaiah runners up. Cool. Nice. Every question was answered correctly by most players. Sweet. For the 3 who wants more practice, again, the best way to get practice is the labs and homeworks. And if you want additional problems beyond that, let me know, and I can try to share them with you. All right. Tomorrow evening, 6 p.m. at Nabrit Hall, which is right across the lawn here, we have the Google STEP internship. This is like the big one if you want to get the STEP internship for Google. So they'll talk about what should go on your resume. The application is going to open September 19th, so they'll just tell you what you need for the application. I think the application is pretty straightforward. You just need an unofficial transcript from this year. I know you don't have grades from this year, so it's really just showing what classes you're in, and particularly showing that you're in this class so that they can prioritize you because you're already working with a Googler right now. And they'll give you all that information tomorrow. So if you're interested, scan the QR code or go to this link now and just fill it out. I think it's pretty quick, 1 or 2 minutes. There will be free food and swag. In fact, I'm in charge of ordering catering, and I wanted to see what people were interested in. There's like 5 places near here that actually deliver that I can pick from. So it's like Chick-fil-A, Panera Bread, Quiznos Subs, Jason's Deli. Do any of them have wings?
If they got wings, choose that spot.
Okay. I'll look for any that have wings. Any other food suggestions? Any other food suggestions? Church's chicken? No. Chick-fil-A?
Who said church? I said pork. Oh, it's great, man. Alright, the first thing you think of is churches. Over Popeyes? That's crazy.
No, it's not.
He said it or. He said or Popeyes, but like, why'd you even mention this? Why'd you even
You said churches.
You said, we don't even Bojangles?
First choice.
Not even Bojangles.
I'm like,
Alright, let's not brag too much. Alright, does Chick-fil-A have any veggie options if there's any vegetarians? They have some salad stuff? Okay.
What about Wingstop?
Wingstop? I can check if Wingstop delivers and see. Yeah. I know the last time they did Chick-fil-A, they did like the nuggets, but our budget is a little bit higher for this one, so they said we can do like the sandwiches. Yeah. So slightly higher. Okay. So again, if you're a freshman student, you should definitely come for this. This STEP internship is targeted for freshman students, so they know that even if you never coded before, your interview will only be in January after you finish this class, and we'll help prepare you for that. If you're a sophomore and you want to apply for the STEP internship, you had to have taken at least 1 CS class before this. So either like CS106 or a CS class in high school. So this would have to be your second CS class if you're a sophomore and you want to apply for this. Does that make sense? Okay. Yeah.
What if I change my major? I'm a sophomore.
Yeah.
I can transfer.
Yeah.
I can change my major.
And is this your first ever CS class? So I guess that's maybe a question better for Nathan. I think like there might be other internship opportunities, but maybe for this STEP internship it might be tough because they want, if you're a sophomore, for this to be your second. But we can check with Nathan at the session, or I can check if you can't make it and let you know. Yeah. Cool. Any questions on this? All right. Fill out the RSVP, ideally before 3 p.m. because that's when I'm going to order the food, and I'm really just going to be looking at responses to see how much food to order. So.
Did you send that to us?
I have not, but it's this link here, or you can like scan the QR code now if you're able.
So, if you are a sophomore and you did switch your major, how do we go about it?
Yeah, so I think I don't know why they do it like this, but they just say if you're a sophomore, this has to be your second CS class for this specific internship.
So would there be other opportunities like?
Yeah, so and I think Nathan will have more of the opportunities. So I don't know them off the top of my head, but I can check and get back to you. Yeah.
Are there also
Study abroad stuff?
or like internships?
Oh, are the internships?
In London,
Yeah, I'm pretty sure for this deaf internship, it's entirely in the U.S. Yeah, so you'd most likely be placed in the Bay Area or in New York. Though the Atlanta office is up and coming now, so they might start opening up some roles here as well. Cool. All right. Sweet. So let's get into if statements versus loops. Let's start with some live coding. So that's STEM Scratchpad. Okay. So let's say, just using if statements, we wanted to check if the user's password was correct. So this is very similar to the last problem that we saw in the Kahoot. So we'll have like some string called attempt. What's the keyword to print out to the user? Cout. What is your password? And then cin to get the data, and we'll store that in attempt. Yep. So let's say the password is 123. We can check. So what relational operator do we put here? Double equals, and then the quote password 123. I saw in people's labs and homework, sometimes they were storing this part in like a variable. You can do that if you want. You can also just compare directly to the literal. So we did stuff like age is greater than 21, and we didn't store 21 in a variable. So it's kind of up to you whether you want to store it, or you can just use it directly like this. So if attempt is equal to the string, and we'll actually do it as it's not equal to, and we'll say, sorry, that's the incorrect password. Okay, so if we're to run this, it asks for our password. Let's say we just did ABC, and it'll say, sorry, that's the incorrect password, and then the program just ends. So let's say you were on a website, you put in your username, you put in your password. Let's say you maybe forgotten your password or you have multiple passwords, and you put one and it was incorrect, and then the web page just closed. That would be a little bit annoying, right, if the page just closed. What would be a better user interface if you typed in the wrong password?
Try again.
Yeah, so it should ask you to try again instead of just shutting down the program, right? But with if statements, you only have one chance. With an if statement, if the user's typed in the wrong password, we say it's the wrong password, and then the program just ends. There's no opportunity to keep asking the user for the password until they get it correct. And so that's where we can use something called a while loop that allows us to keep doing something while a condition is true. So we can do here instead, we change the if to a while. So now this is going to keep running while attempt doesn't equal password. So let's see what happens if we run this. What is your password? We do ABC. And then it just keeps printing out, sorry, that's the incorrect password. And I'm going to stop it before my computer crashes. All right. Is this a good user interface? If you're on a website, you type in the wrong password, and it keeps telling you, wrong password, wrong password, wrong password. All right. So how could we make it better? So we do want to print out wrong password, but then what do we want to do after that?
Stop.
Yeah, so we want to tell the user to try another password, right? We want to give them another opportunity. We don't want to just keep telling them that they put in the wrong password. So as you can see, whatever code is in here will keep running while attempt doesn't equal password. And so in here, we can tell the user, type in, like, try another password, right? And then we can store that in attempt. So now let's run it. We type in some random thing. Let's put a new line character here. All right, so now we said, sorry, that's the incorrect password. So that was line 11. Okay, let's step through it again. So what is your password? Attempt is equal to ACE. So what happens at line 10? Is this true or false? ACE doesn't equal password 123.
That's true.
That's true, because they're two different things. So ACE is different than password 123. So then we come to line 11, and we print out, sorry, that's the incorrect password. Then we come to line 12, and we say, try another password. And then we ask the user to type in a password. So let's say now they type in 123, right? That gets stored in a temp. At the end of this loop, it comes back to the top and it checks the condition again. So now what's going to happen at line 10?
Sorry, it's incorrect.
Yeah, so 123 is different than password 123. So it's going to run the loop again. So when I enter, it will do it again. Sorry, that's still the incorrect password. Try another password. This time, let's type in the correct one. So password 123. So now we come back to line 10. And what happens in line 10?
It's gonna be the same thing. It's gonna be false.
Yeah, so password 123 is going to be equal to password 123. So this is going to be false. And if it's false, then nothing in the curly braces runs. So it'll come down to line 14. We could have had like a statement at the end just to show it, but it'll say, all right, good, program exited. So it came down to line 15. And if we had like some more code here, that would have run at line 15. So I know earlier people were asking like, why would we ever use this like not equals to symbol? And this would be a very good example, right? If the password is not equal to the expected password, then we ask the user to type in their password again. And we keep doing that while that's true until they put in the same password. Then this will come out to false, and then we'll go along with the rest of our code. Question, yeah? Yep. Okay, so let's see what the exact syntax looks like with this. So again, the reason why we were practicing if statements so much, and especially the part with the relational operators in the condition, is because we use the exact same thing with while statements, with while loops. So what are the differences? The differences are the keyword. So with if statements, we use the keyword if. With while loop, we use the keyword while. So you can't name a variable while, because that's a specific C++ keyword. That tells the computer we're going to keep doing a code perhaps a bunch of times. The condition, what values must it come out to? True or false. If it's true, the code in here is going to keep repeating. So the code will run, it'll get to the end, and it will jump back to the start, and it will check the condition again. And if it's still true, it'll come down, and it'll do it again, and it'll keep doing it until the condition becomes false. So generally, whatever variable you use in the condition, you have to modify it in some way here. Otherwise, the code will keep running infinite times. And we'll go into more detail on that in the Wednesday lecture. Yep. Any questions on the difference between these two? Yeah. Yeah. Oh, yeah. I should also take a screenshot and put it in. Dang. Let's make me authenticate. Okay. I'll add it to the slides too after class. Yeah, question.
So do you think it's better to use not equal when you're using a while loop?
So in this case, we kind of had to use the not equals to, because we only want to ask the user to type in a password again if their initial attempt wasn't equal to the password. So yeah, like I'm trying to think for this case, I don't think there's any way you could have done it without the not equal symbol. Yeah. Mm-hmm.
If you put a while loop at the top of your code and you have if statements below it, will the while continually run to check the if statements or to check?
Like if your if statement was inside the while loop or after the if?
Before the if the if statement was after the while loop.
If it was after, so this while loop will just keep running for here, and then after it finishes, then the rest of the code will just run as normal. So if you have an if statement after, it will just run once.
Okay.
If you put the if statement inside the while loop, then the if statement could keep getting checked every time.
Oh, okay, I see. Thank you.
Okay, how are we on time? Okay, we'll just do this one as a class. So what are some real world examples where loops might be useful? So the one we just talked about was checking if the password was correct. We keep asking the user for their password until they get it correct. Yeah, did you come?
Oh, well, no, that's kind of the same thing.
I was gonna do like when you look into your phone for like your facial identity.
Yeah. Yeah. So it keeps checking until like your face actually matches. So if you showed it to different people, it would keep saying no, try again, until it sees your face, and then it would accept and open. Yeah, Jamal.
Not having or insufficient funds, that like the low credit card thing.
Okay, so while your funds are low, it might not let you use your credit card, and it will keep doing that check every time you try to make a purchase. Yep.
On the microwave, while the time is greater than 0, cooks it.
Yes, so in a microwave, it has to keep checking if the time is greater than 0. In a microwave, let's say it only did the check once. So you put in 50 seconds, it checks is time greater than 0. You do that check once and it's true.
And then it turns off the microwave.
Yeah, or it could also just like keep running indefinitely. So because it'll be like true, so it's like, oh, cook the food. But then it never checks again whether it should stop cooking the food. But in a while loop, we can keep checking every few milliseconds, is time still greater than 0? And if it is, keep cooking the food. And as soon as it equals 0 or is less than 0, then it stops cooking the food. Right? Yeah.
Do microwaves have software?
Yeah. Like for their digital display. That's all. Yeah. It'll be like embedded system. So it won't be as powerful as these computers, but there will be a little bit of software that's doing that. It's literally doing a while loop. Like your microwave is doing a while loop and is tracking the time. And as soon as time is less than 0, it stops. All right, so yeah, so microwave example, keep checking if time is greater than 0, and keep cooking food. Facial recognition, password, cool. Okay, so we're almost there, sorry, I think we still have 1 more minute. So while loop syntax, again, keyword while. The condition must be true or false. I literally copied this slide from the if-else statement, but I switched 2 things. One is, instead of running this once, I said keep repeating the while condition while it's true. And then I switched the if to a while. So that was the only difference from the if syntax slide. And then here's what the flowchart would look like. So using our password example, we still have the diamond because it's still a conditional expression. If the attempt doesn't equal password, if that's true, we come here and we ask the user for another attempt, and then we come back and we check their attempt again. If it's still not equal, we do it again. And we keep doing this loop until they put in the right password, and password is equal to password, and then we continue with the rest of the code, which might allow website access. Yeah? Again, we're gonna be doing more stuff with while loops on Wednesday, so don't worry if you didn't get all of it now. Again, stuff is due today. Most people are almost there. I'm seeing some lagging on Lab 3 and Homework 3. If you need more time, email me, and I will probably grant an extension, but you have to be proactive about doing it. I'm not just going to grant the extension for everyone. Yep. And if you came in late for attendance, please come up.